Okay guys, so now it's time for science. We just finished social studies, so now we're ready to start on a completely new chapter of science. So we are going to be working on chapter 9. So you need to go ahead and open your science book up to page 410. You should also have your vocabulary notebook open to the first clean page in your science, in the science section. Go ahead and label the notes. We are on chapter 9, lesson 1, and make sure you have the date, March 23rd, 2020. Okay, and now you should be looking at page 410. Remember, if I'm going too fast, pause the video. If you miss something, go back, but make sure that you're following along in your book. If I draw diagrams on the board, just go ahead and copy them into your notebook. Okay, so we are on page 410. So what I want you to do is I want you to look at the box that says look and wonder. Read along with me. In winter, rain can freeze to ice. The warmth of spring melts the ice. How can you tell the difference between rainwater and ice? And I want you to think about the answer to that question. Think about it in your head. You don't have to answer out loud. Okay? So how can you tell the difference between rainwater and ice? Look at this picture. Is this rainwater or is this ice, and how can you tell? Okay. Go ahead and turn the page and look at page 412, and we're going to go ahead and start with the main idea in that little bookmark all the way to the left. Main idea. Matter can be described by its properties, including mass, volume, and state. Now that may not mean much to you right now, but as we go through this lesson, you will start to understand. Okay. Make sure that you're reading along with me. If you want to pause it and read it yourself out loud, you can. You'll just have to fast forward later, but go ahead. The easiest thing to do will probably be to just read along with me. Okay. What is matter? When you mix cornstarch and water, you get a thick, gooey substance. You can see and touch it. It takes up space in the container. Like many things, this substance is matter. Matter is anything that has mass and takes up space. So our first vocabulary word for chapter 9, lesson 1 is matter. And matter, you should be copying this into your notebook as well. Matter is anything that has mass and takes up space. So some examples. This pen is matter, your textbook is matter, you are matter, your hair is matter, air is matter. Even though we can't see it, it's still there. It takes up space, it takes up the rest of this room that we're not in, so the air is matter. Anything that has mass and takes up space is matter. Most things are made of matter. The air you breathe and the book you are reading are made of matter. Light and heat are not matter, however. They don't take up space. So the difference is, air we know is in this room. It's everywhere around us except for where our bodies are, because that's where our bodies are. But light and heat is different because it's not an actual thing that takes up space. It's just there. It's a way that we feel or something that we see, not something that's actually there. One way to describe matter is by its properties. A property is a characteristic that you can observe. Remember, characteristic means the same thing as trait. So our next word is property. And property is a characteristic or trait that you can use that you can observe. And now we have some examples. Color, shape, and size are some properties of matter. So that's not everything, but those are some of the most basic. Let's add that to our definition. Let's put a semicolon, which means our definition continues. Includes color, size, and shape. So I could say the property of this pen is that it is black and white, it is small, and it's kind of shaped like a cylinder. Okay. Matter has mass. One very important property of matter is mass. Mass is the amount of matter making up an object. So that's our next word. Mass. Not like church, but this is a different word, so it's a homophone. Mass is the amount of matter making up an object. Mass is often measured in units called grams or kilograms. To measure mass, you use a tool called a balance. So if we look at this picture at the bottom of page 412, we see a balance. It's different from a scale because this balance actually kind of compares the mass of two different objects. So on this balance that we have right here, make sure you're paying really close attention to this description or this discussion about this diagram because you may see it later, hint, hint. So if we look at this picture down at the bottom, we can see a balance. And on one side is a rock, and on one side is a feather. And so this balance compares them. So we know one is heavier just by looking at the picture. We can tell that the rock is heavier because it's farther down. Think of if you have a seesaw and you're sitting on a seesaw with your friend. The person who's heaviest is going to go down to the bottom, and the person who's lighter is going to go up. And that's the same concept as this balance right here. We can tell that the rock is heavier because it's further down. Also, we can tell because we know what a rock feels like and what a feather feels like. Okay. Next, matter has volume. Another property of matter is volume. Volume is how much space an object takes up. We measure volume, that was our next vocabulary word. So number 4 is volume. Volume is how much space an object takes up. So it's different from mass. Mass is the amount of matter that's in the object. Okay? So that we can kind of figure out by which one's heavier or lighter. Volume is how much space that volume takes up. So that would be more like, is it large or is it small? Now you may think, well, usually if something's larger, it's going to have more mass, but that's not necessarily the case. We measure volume by counting the number of cubes that can fit in an object. We can also measure volume with tools like graduated cylinders. Some properties are unseen. Properties that cannot be seen can still be measured. Take magnetism, for example. This is the ability of matter to attract certain metal objects. So what that means is think of a magnet. If you have a magnet let's see, I have some magnets up here. This magnet right here. And I'm holding it up to a metal object. Well, the board behind it is metal, so that's why it sticks. When I hold it up to that metal object, I can't see how that, there's no type of light or color or anything that shows that metal object attracting the magnet. When I hold it this close, you can't tell, but I'm not right up on the board. I can feel that the board is pulling this magnet, but I can't see anything like that. I can't see little hands coming out trying to grab the magnet and pulling it close. It just happens. So that is a property that cannot be seen. Another unseen property is the ability of matter to dissolve in a liquid. When a substance dissolves, it blends in and seems to disappear. Sugar and salt will dissolve in water, but sand will not. So think of it. When you look at some salt, you look at a teaspoon of salt, you can't see that it can dissolve. That's not something that you see. But if you put it in water, eventually, after a little while, it will look like it's not there anymore because it has dissolved. Same with sugar. After a while, you put it in water, and after a while, you can't see it anymore. It has dissolved. We can't look at that sugar or salt and say right away, oh, it can dissolve. That's something we can't see. Sand is something, think of the beach. If sand was able to dissolve in water, we wouldn't have any sand on the beach. But sand just sits. So let's look at the diagram to the side on page 413. This diagram tells us, it kind of shows us what that paragraph about unseen properties, what it says. So we see magnetism at the top, where we see this horseshoe magnet and all these paper clips sticking to it. We can't see what's holding those paper clips to it, but it is there. So that's an unseen property. Then we can see where, where we have salt in water, and that is able to dissolve, whereas sand will not. The bottom cup we'll talk about as soon as we read this next part. Useful properties. Properties help people choose the right kinds of matter for different jobs. When strength is needed, iron is a good choice. It's good because it has a lot of mass, so it's really hard to break because there's so much mass in there. Wood is better when you need a light material that can easily be shaped because it is lighter, it has less mass. Buoyancy is a property that helps us build boats. Buoyancy is the upward force of a liquid or gas on an object. So that's our next word. We have buoyancy. Make sure I spelled that right. And buoyancy is the upward force of a liquid or gas on an object. So basically, buoyancy tells us, will it float? Now we have liquid or gas, because think of a boat. A boat is on water. It has buoyancy because this water is able to push it up so that it can stay above water. A balloon is another example of something with buoyancy. Well, if it has the right material inside of it. Because it is able to float on the air, because the air has an upward force on that object. A rock, however, does not have buoyancy. It is not going to be able to float. If you throw a rock up in the air, it's going to come right back down. We have some buoyancy on water, but none in the air. Because if you're in a swimming pool and you float on your back and you get some air in your chest, you can probably float for a little bit. But you can't do that in the air. There are other objects that are buoyant in the water, but not in the air. Really a lot of things. Even a balloon with just regular air has a little bit of buoyancy, because think about if you throw it up in the air. It kind of falls down more slowly. So that means there is a little bit of that upward force pushing on that balloon, but not enough as if it was filled with helium and it's able to stay in the air. All objects are buoyant. Some objects are so buoyant that they float. So that means even a rock, this rock has some buoyancy, just not very much at all. Very, very little buoyancy, because it's not going to float very easily. It's not going to float in the air at all, and it's really not going to float easily on water. However, water is able to push it a little bit. It's like if you throw a rock inside a pool, it's going to act a little kind of like that balloon with your air in the air, where it'll fall down slowly. So there's a little bit of buoyancy. Okay, so now we can look at that picture at the bottom cup on page 413. We have some objects can float in water, other objects sink. So what it looks like is in this cup they have a cork. At the top, corks are very light. They have a lot of buoyancy on water, so they are able to float. They really don't have any buoyancy in air though, so you can't throw it up in the air and it floats. And then it looks like we have sand at the bottom. Sand has very, very little buoyancy. It is not able to float. Okay, let's look at these quick check questions at the bottom. What we're going to do here is I am going to ask the question. You are going to pause the video, come up with an answer, write it in your notes underneath this diagram, because remember, you're drawing the diagrams with me. If you need to go back and do that now. I'm going to ask the questions. You're going to pause the video, write your answer, and then play the video, and I will tell you the answer. Please make sure that you are writing the answer. Don't just wait for me to answer it and then write it. Okay, so the compare and contrast. How are mass and volume alike? How are they different? Pause the video and write your answer. Then play it, and I will tell you the answer. And then you can check and change your answer if needed. You do not need to use your red pen because this is not graded. However, I do want you to use your thinking skills to find the answer before I just give it to you. So, the answer is, they are both properties of matter. They are alike because they are both ways to describe matter that you can observe, whether that's with your eyes or by putting in water or by seeing if it sinks or if it floats. Okay, they're different because mass is the amount of matter that makes up an object. So we would describe that by whether it is heavy or it is light. They are also different, and then volume is how much space an object takes up. So we would use that more, we would describe that as more, is it small or is it large? Okay. Now, the critical thinking question. Again, as soon as I'm done asking this question, pause the video, write your answer, and then play the video to check. How do you know that your desk is matter? Okay, so the answer is, you should have paused the video and written your answer, now you should be checking it. The answer is that we know our desk has matter because it has all of those properties. It has a mass, you can lift it up and you can feel whether it is heavy or light. It has volume, so you can tell whether it is small or large. You can tell that it takes up space. And it also has a color, it has hardness, it has a shape, it has a size. All of those things tell us that it is matter. It takes up space and it has a mass. So now you should be turning the page. You should be on page 414 and you should still be following along. What are the states of matter? Now we've kind of talked about this when we talked about the water cycle, and we talked about how there's different states of matter. We had the solid, liquid, and gas. We're going to go more in detail about this. So you've already heard this. Now we're going to learn a little more. Matter is found in many forms. We call these forms states. Solid, liquid, and gas are the three common states of matter on Earth. Now we're going to talk about each of those. We know solid, water in its solid form is called ice. Water in its liquid form is called water. Water in its gas form is called water vapor. So remember, we talked about that already. Well, now we're going to talk more about what makes them solid, liquids, and gases. Solids. A solid has a definite shape and takes up a definite amount of space. So that's our number 6. We have solid. And a solid has a definite shape and takes up a definite amount of space. So what that means is if you have a solid, think of your ice. You can't mold it. You can't reshape it. It's going to stay that shape of that ice cube until it melts. Now you can break it, but even then you still have all the pieces. And if you somehow were able to glue all of those pieces of that ice back together, it would be the same shape. It would take up the same amount of space. It would look the same. It would be the same size. It's not going to change something like that. The particles of matter in a solid are packed together tightly. Often, the particles are packed in a regular pattern. This textbook and your desk are solids. What other solids can you name? This marker, my pointer, this eraser, oops, me, you, your chair, your house. Those are all solids. You can't just take them. They're not like clay where you can take them and you can mold them and turn them into something else. If you look at this saxophone at the bottom, it has a diagram of what those particles look like. So we have a saxophone and it says, the caption says, this musical instrument is a solid. Its particles are packed closely together. So that means if you magnified it really far, you'd see that all those little particles, look at those little blue dots. Those model the particles. They are very close together. There is a pattern to them. They are not easily moved because they are so closely packed. So that's how you can tell that it is a solid. That's what makes something a solid. Liquids. Orange juice is a liquid. Unlike a solid, a liquid does not have a definite shape. It takes the shape of its container. However, a liquid does take up a definite amount of space. So, if we set this definition up the same way that we did a solid, we have a liquid. Oops, I just realized I forgot the either. Which does not have a definite shape because, oops, think about it. If you have water and if I had water and I were to pour it in this cup, that water would take a different shape than if I poured it into this vase. So even though they both have water in them, the water in this cup is a different shape than the water in this vase. So that's what that means. It doesn't have a definite shape. It's going to take the shape of whatever container you pour it into. However, it is like mass because it takes up a definite amount of space. If I have a measuring cup and I fill that measuring cup up to the 1 cup mark, and then I pour that 1 cup of water into a coffee cup, it's going to look different. In that coffee cup, no, let's think a pan of water, a big pot of water. I take my 1 cup in my measuring cup and it's almost to the top, because I have a measuring cup that has up to 1 cup, and it's going to fill almost to the top. But then if I pour it in that really big pot of water, it's a lot lower because it doesn't have a definite shape, but it still takes up the same amount of space because I can pour that water back and forth from that 1 cup measuring cup into that large pot of water, and I'm going to have the same amount of water every time. It's going to take up the same amount of space unless I spill it or something like that. But it's still going to be 1 cup of water whether I pour it into a coffee cup or into a huge pot that goes on your stove. It's still going to be the same amount of water because it takes up the same amount of space. Consider a glass of juice. The juice has the same volume whether it's in a glass or a graduated cylinder. A graduated cylinder is like that measuring cup. If the juice spills, it will spread out. Its volume stays the same. So if you take a cup of orange juice and you spill it on the floor, well, it definitely looks a lot different, but it's still the same amount of juice, whether you spill it on the floor and it's all over the floor, or if it's in that cup. In a liquid, the particles of matter can move more than they do in a solid. The particles can change place and slide past one another. They are farther apart than in a solid. Water, milk, and oil are all liquids. What other liquids can you name? So if you look at the top and you look at that orange juice, the caption says, juice is a liquid. Its particles are less tightly packed as those in a solid. They can move past one another. And then if we look at those particles, that little inset picture, we can see that they're not as close as the particles in the saxophone. And you can also see how they have those little trails. That means they can move. That's why, think if you're in a really, really, really crowded room. It's really hard for you to move, and you're going to end up filling the whole room, and there's going to be the amount of people that can fill the room. But in a room that's not as crowded, you're able to move back and forth between all those people. Maybe not as easily as if there was no one or only 2 or 3 people in the room, but you're still able to move. So your actual shape of all the people in the room is going to change. If you're so packed into a room that you can't move, like in these solids, the people are going to take the shape of the room. They're going to stay the same shape. Gases. Helium is an example of a gas. A gas does not have a definite shape. In that way, it is like a liquid. So we can go ahead and start our definition, but we're not quite done yet because we want to set it up the same way we have this one so that we can see the similarities and the differences. So number 8 is gas. Gas does not have a definite shape. So like a liquid, it takes the shape of the container. Think about balloons. Well, you have just those little balloons those little plastic balloons that look like this, kind of. That's not a bad drawing. You don't have to draw this because I'm just drawing a picture because I don't have one here to show you. And then you have those fancy balloons from the grocery store that are like metallic and say happy birthday or something on it. Those are filled with helium, which the helium takes the shape of those different types of balloons. Sometimes you even have balloons that look like a cube. Or balloons that look like an animal. Don't make fun of me. So, helium just takes the shape of the container it's in, just like a liquid does. I'm missing my helpers. I have to erase the board all by myself. However, unlike a liquid, a gas does not take up a definite amount of space. So it doesn't have a definite shape, nor does it have, does it take up a definite amount of space. So you can imagine that in that if you blow up a balloon, you're blowing out gas, and it will fill up that balloon. If you're blowing into a balloon, it will fill up that balloon, and it will take the shape of the balloon. But if you are just blowing into the air, it doesn't just stay right in front of you all day long, where you go around and you walk up to somebody and then they feel that air that you just blew out. It just goes off into space, into the rest of the air, and it just goes away. It doesn't go away, but it just goes off into the air. The helium, so this will explain that. So helium, which is a gas, fills the shape and space of its container. The helium in a balloon takes the shape of a balloon. That's like my drawings. If the balloon bursts, the helium will spread out into the air. If you pop a balloon, you don't just have this invisible little thing of helium that's shaped like the balloon. It just goes off into the air. It spreads out. So it's like that juice, except even that where that juice spread out across the floor, but even then, that juice eventually stops. And then you wipe it up. Helium, or a gas, will just keep going and going and going and going and going. In a gas, the particles of matter move about freely. The particles move farther apart from one another to fill the space around them. If there is less space to fill, like a small balloon, the particles are closer together. A gas always spreads out to fill its container. So that means, like that popped balloon, there's no longer a container to hold that helium. So that means it's going to spread out and out and out and out and out and out forever, because there is no container for it to fill. Let's look at this picture down at the bottom. We have some balloons, and the caption says, inside these balloons is a gas. Gas particles move about freely and spread apart. So if you look at this little inset, those particles inside, you can see they are way less packed than the liquid, and they're able to move about freely. The only thing that stops them is the edge of the container. That's the sides of that balloon. But if there is nothing there, it just keeps going. Think about you on the playground. In here, you're able to move about pretty freely because there's not that many of you, so that you can go all the way to the edges of the classroom. But if these edges weren't here, like out on the playground, you can keep going and going and going, and then go through the gate and keep going and going and going and going and going for as long as you want, forever if you really wanted to. That's like the particles inside a gas. Okay, so now we're going to look at those quick check questions again. You're going to do the same thing. I'm going to ask the questions. You're going to pause the video, write what you think the answer is underneath your words, and then play the video and I will give you the answer. Same thing for the compare and contrast and for the critical thinking. So again, I will ask the question, you will pause, write your answer, and then play the video to check your answer. If your answer is incorrect, go ahead and erase it and change it with your pencil. Always pause if you need a moment. Okay, compare and contrast. How are solids, liquids, and gases the same? How are they different? Go ahead and pause the video, write your answer down, and then play it to check your answer. All solids, liquids, and gases have mass. That's how they're the same. They all have mass. They are different because solids and liquids keep the same volume, but but gases don't. Solids keep the same shape, but liquids and gases don't. Particles in solids are held tightly together, like that picture next to the saxophone, whereas particles in gases can move about freely, like in the picture of the balloons, and liquids are kind of in between. They are able to move about freely, but there's still a lot more of them, so not as freely as they could, to where they can just disappear off into the air if they want to. Okay, now the critical thinking question. A cornstarch and water mixture has both liquid and solid properties. How would you classify it? So this is a thinking question. I want you to think about it. The cornstarch mixture can be classified as both a solid and a liquid, since it has properties of both states of matter. This is a weird one. This is another property that we aren't really going to talk about, but it actually, not a property, a state that we are not going to talk about it, but there is one that's kind of halfway between a liquid and a solid. Mud would be another example. Cake batter would be an example, and then there's lots of other examples of this state of matter, because they have properties of both a solid, where sometimes they do take up a definite amount of space, but sometimes they don't. They do have a definite shape, but sometimes they don't, so it's weird. They have properties of both. They're kind of in between. What happens to the matter we use? You use matter all the time. The food you eat is matter. Your chair is matter. You even breathe matter. Some matter, like air, can be used again and again. Other forms of matter get thrown away. Too often, matter becomes trash and it goes into landfills or oceans. So what that means, air, we can breathe it over and over and over again. And then the trees breathe it in, or the carbon dioxide, and then they let out oxygen and we breathe it in. And it's kind of going back and forth like a cycle, kind of like the water cycle. But other things we can't reuse. Think of an apple core or the wrapper from a candy bar. We're not going to use those again. So they go into the trash. Some trash, like it says, doesn't go away quickly. Many people choose to reuse matter. This is when you use something again instead of throwing it away. An egg carton can be used to plant seeds. Are there other uses for the things you throw away? Well, you guys have been bringing me those paper towel rolls and toilet paper rolls for weeks now, so that we can use them for projects during summer camp. There's lots of things that you can reuse. If you have a water bottle, like one from the grocery store, instead of just throwing it away afterwards, you could use it again to hold water for your next. You can just fill it from the sink and use it again. Even though it's a one-time use water bottle, you could use it again for anything. Or you could cut it apart and create some kind of project. Or you can use one of those jars. You can use it to make one of those jars, like what Miss Martin uses with the glitter and the colors. So there are lots of things that can be reused. Matter can also be recycled or made into something else. Cans, paper, plastic, and glass can all be recycled. What else can you recycle? Let's look at this diagram on the side on page 416. Pay close attention to this because you might see it again. So this diagram classifies these objects into two different groups. It classifies it into objects made by people, which we can see at the top in the blue box, and then objects made by nature, or objects in nature, which we can see in the green box. So everything in that blue box was manufactured. We have a piggy bank, some flip-flops, a stopwatch. Those were all manufactured. We can't just go outside and go find a random piggy bank growing out of the ground. I mean, you may be able to find one, but that means somebody threw it there. Whereas a pineapple and these gemstones and this log, you can go out and find in nature. It was created by nature. They are natural. Look at this diagram and think, how else could you sort them? So that clue is, think of the properties of each object. You could sort them into maybe things, you'd have to add more, but things you could eat. You could, let's see, they can be sorted based on their color, on their size, on their shape, how they are used, how hard they are. There's lots of different ways that we could just take these 6 objects and sort them into different groups. Some of them we just may not have 3 items in each group. Okay, now let's look at these quick check questions. Remember, just like all the others, listen to the question, pause the video, write your answer, play the video, and check your answer. So compare and contrast. What is the difference between using matter and reusing matter? Pause the video, write down your answer, and then check. Using matter can mean using it more than once, it can mean using it up, or it can be throwing it away. In all of those ways, you are using that matter. So you can use it more than once, something like a water bottle. Or you can use it up, like the yogurt in a tub. Or you can throw it away, like that candy wrapper. But reusing matter also means using it more than once. But it can mean using it more than once, like that water bottle, where you fill it again with water and use it the next time you go for a walk. Or it can also mean finding a new purpose for something that's already been used, like how we will use the toilet paper rolls and the paper towel rolls over the summer. It can be like some of you always want to take the empty tissue boxes and turn it into a guitar. That's a way of reusing them. Both of them are important. Reusing, any way that we reuse it, whether we reuse it for the same purpose or we reuse it by making something new, they're both important. The critical thinking question. How many uses can you think of for a milk carton? List them. Now this is a question that's completely up to you. So I want you to write your answer, but your answer will not be wrong, unless you're saying none. Your answer will not be wrong, so I will not be correcting you. With Chapter 9, Lesson 1, so what I want you to do now, I want you to do this right now as soon as I finish, is the independent practice. Now these are those diagram sheets. That's the first, after you have your packet of work. And then on the front is the day it's for, and then what we're doing that day. So the first page is the independent practice. It says it right there, independent practice, Monday, March 23rd. So what you're going to do first, I want you to do that right now as soon as you're done watching this video. It's one of those diagram sheets. So you're going to do the front, and then you're going to do the back. Make sure to write in complete sentences. Make sure to fully answer the questions. Each picture has the page number that you can find it in your textbook so that you can see a better version of the picture. We have this balance that we looked at on page 412. And then we have this this diagram that classifies the object on page 416. Remember, some of the questions can be answered just by looking at the pictures, but some of them you may have to use what you read in your book. Sometimes that information will be near the picture. Sometimes you have to take what you read in the book and come up with your own answer. So you need to, as you read the questions, you need to figure out, is this a question I can answer just by looking at the picture? Is this a question that the answer is in the book and I just have to pull it out? Or is this a question where I have to use what I read in order to come up with a brand new answer? As soon as you're finished with the independent practice, you may start on the homework, or you may wait a little while and work on that a little later today. That's up to you. That's up to you, whether you want to start it right away or wait for the rest of the day. Independent practice, please do it right now as soon as this video's over. Homework is an outline. It says homework Monday, March 23rd. It's the outline. You've done these a million times. It's front and back. Make sure that you choose the correct answer. And when you get to the critical thinking question, remember, it says, do you think you can describe an object without using its properties? You need to tell me yes or no and why, and then give me an example. Come up with a full and complete answer. There are several lines, so you need to try to fill them. Okay, good luck, and if you have any questions about today's lesson or the independent practice, You can Skype me between 1 and 5, or you can FaceTime me. Just get in touch with me whenever you have a question. If you can do some of it, go ahead and do some of it now, and then wait until later when I answer your question. If not, good luck, and I will see you again tomorrow.